Alright, so we're gonna
That was good.
We're gonna continue 9-4. We're gonna continue looking at example 2 now. So example 2 says sine 4x equals -2 sine 2x. So given what we covered yesterday, what we finished going over for 9-3 and what we started with 9-4, I want you guys to attempt this one on your own. I want you to try to start this one. If you're not able to completely finish it, that's okay, because we're still starting out with these equations, but I want you to at least try starting this problem. Come up with ideas of how you might solve this equation. Because it's one thing to watch me do it, but I need you guys to understand that when you're watching me do it, basically you're watching me tell you how to do it. So I need you to be able to do it on your own. So that's what this is going to be an opportunity to do. Try to come up with ways that you can solve this equation on your own.
What are you?
We're doing it right. Why not? I just put it to 0. I did rewrite it. Oh wait. Oh wait, never mind.
Oh, did she grade them? They get a 16 out of 20. Okay.
You need to divide a 16 out of 2x by 4x.
Did you do the FRQ?
Oh god. I don't want to know.
I got a 22 out of 25.
For this one.
So, could have been worse. Like an 88. If it's 4x, like what do you do? I mean, I understand you're going to change this to apply to the 4x, but like what is changing? By like making that a 4 by squaring?
So you're trying to use this, right?
Yeah. Yeah.
This was a 4.
This would be half of that or whatever.
Oh, I got a B.
So here,
Only reason is because.
So is it 2? Okay, so it's 2x.
you're gonna have this.
Okay.
I got an only reason.
It's on mine. 2 sides. You would have been better
Yep.
if you. Is this between?
So can you substitute those in?
Oh, well, I'm sorry. You're gonna hang your people.
Oh,
I don't know. The sides is between.
I'm-
23.
I got an 84 and I failed completely. I'm heavy back.
So are we like making it to the other side or?
it's 4 to
No.
sin x.
So we're solving
Is
this.
that-
So now you want to solve for x.
Then I did or sine 2x, so sine 4x.
She give it back?
Oh, we have to make this.
Okay, what was it?
Because I wanted you to say that.
No.
No, she didn't really count it on trying to know what it was or not, because half the stuff I didn't know what the heck it was.
Sam, are you trying the example, please?
She
I'm just trying to
did
figure
it
that
based
out.
on if you added like,
So this
if there was a structure, if you added like, the prompt into what you're saying, it gives like that. So it didn't matter if you knew what it was, I didn't
I tried
know.
it and I gave up.
Oh, and then you can
Try
buy
it again.
Yeah, I tried it back here.
So sign to activate.
Why did you
Sum for x equals.
Well, let me come look and we'll see.
Would you
Huh?
combine the two?
Can you?
I think.
Oh, we're sorry.
I didn't work great in English.
And then you, oh.
I got a 1B, and that dropped me down.
What did you try?
One.
So you do that, and then you add another two beside two x, and then combine them.
Okay, so you're gonna try with this, right?
She just said she
So can
doesn't
you
know.
put it, so can you put that in?
So, okay, so you get these,
What's so funny?
So that's what you want
I
to
was
say.
curious why
you do that, you ignore the two,
Equals that negative.
you find it, and then at the end you divide by whatever it is.
True.
Okay. Oh,
And when you
this
want
is
to solve an
like,
equation,
Alright, so that's it.
what's the particle?
the last part of 8-4.
So we want to solve for x, right?
It's like the last part of 8-4 that we did.
Is x a variable?
Yeah.
So.
Alright, now I don't feel like I have to study this.
Kind of help along with solving.
Now I don't care.
If you have this on one side.
That's really weird how that works. Bless you.
Thank you.
Well, you, if you can, but we should make those
Three
that
sets
negative 2 sign x over to this side. So you have this on one side, and if you equal it to 0, usually that means it goes 0. Ultimately, we'll probably end up there, or pulling something out, that kind of thing. So write down all the equations.
What? This is the other thing?
Yeah.
Yes, you can. You can do
Oh, God.
Okay, so you just did that equation. So rewrite that. What's that?
Bam.
Give this all together. So like, we're ultimately trying to solve for x.
This one
And
I'm
then
saying.
it expands, right?
This one I'm saying.
So, normally when we're solving the equation, we usually set everything equal to 0. So how can we get this to
You're being so rude right now.
Then you can't do it.
So you move this over
And
here?
then you do sign x.
Yeah.
Were you like exhausted after having to swim on that cruise so long? Used to it.
Okay, now it equals
When you
0.
ask them.
I don't hold this one.
Really?
So now
Well, I
we
can
do
see
that.
mine, but if I start
And see if
laughing
there's some way that
now.
you factor
Start
it.
laughing.
Yeah.
Now,
It's bad. I had my brother, I was watching it. He jumped in the deep end and like 8 feet.
alright.
And he jumped in and saved him. So I laughed and I started laughing.
Alright, so let's take a closer look at this. It looks like you guys, most of you are kind of attempting, you know, you've gotten a little bit.
Something that stumped it.
So when we look at these equations, essentially we're solving for x. So we want a way that we can simplify this equation as much as possible so that it makes it easier to solve x. So, well, a lot of people, your first step was rewriting this sine 4x. And rewriting this sine 4x kind of goes into what we talked about yesterday, that if we didn't always have a 2 here, we could still rewrite it using our double angle identities. So, some of you rewrote it as sine 2x plus 2x, which is fine. That goes back to using the angle identity that we learned in 9.2. But you also can, if you remember the rule for ones that if or pattern anyway, for the double angle identity, that if this wasn't necessarily a 2, that we could still rewrite it using the identity that our angles became half of this original angle. So if you didn't want to do it this way, you could still rewrite it as 2 sine 2x cosine 2x. That was when we changed our angles to half of this angle. So either way is fine. So then that is still equal to negative 2 sine 2x. Now when we are solving equations, we usually try to set our whole equation equal to 0, right?
Yep.
So that we could eventually factor or pull something out or something like that. So if we want to get this equation to equal 0, what do we have to do?
Add 2 sine 2x.
So we have to add 2 sine 2x to both sides. So we get 2 sine 2x cosine 2x, and that, oops. And then we're adding the 2 sine 2x, and now this equals 0. So once we get to this step, oops, I forgot a name, sorry. Once we get to this step, we need to look at each of our terms. Is there something we can do with this equation, the way it's written now?
2 sine 2 sine.
We can pull out a 2 sine 2x. And then we're left with cosine 2x plus 1. So now this should look like an equation that we've solved, or that you can solve, or that we've solved before. So when I have two factors multiplied and they're both equal to 0, what do I do?
Then you just equal to 0.
I set each one equal to 0. So I'm going to have 2 sine 2x equals 0. And I'm going to have cosine 2x plus 1 equals 0. So now these should look like problems similar to what we did in 8.3. So if I want to solve this 2 sine 2x equals 0, what do I have to do?
You have to divide by 2.
So I have to divide by 2 first. So I'm going to end up with sine 2x equals 0. What did we do to solve sine 2x equals 0?
You set what sign is at 0, and then at the end, the pi ratio that you get, you divide by 2.
So we ignore this 2 to start out with.
Yeah.
And we just solve for sine x, and then the angles that we find we set equal to 2x, and we solve for x. Okay, so if we're ignoring the 2, we're finding sine x. I'll do it off to the side here. We're solving sine x equals 0. Where is my sine x equal to 0?
0 is
Well, sine is y over r.
So sine equals y over r. Okay, that's kind of our first step to looking at where sine x equals 0.
Perhaps pi.
So when we look at the coordinate plane, we're looking for where y equals 0 then. So you said pi, so that's right here. And where else is y equal to 0?
0.
At 0.
Pi.
So we just plug a 0.
Whatever you wish to call it.
So we end up with 0 and pi for our angles for sine x equals 0, right? So now if we wanted to solve the sine 2x equals 0, that's when we're going to go into, we have 0, and remember I said you want to add and subtract that 2k pi still. It's especially important when you have that 2x. So here we're going to have still that plus or minus 2k pi, and then we have pi plus or minus 2k pi. And we're setting those equal to 2x. So I ran out of room over here, so I'm gonna move over just so I have more space. Alright, so now I want to solve for x. So now is when I divide by my 2. Exactly, Shemaya. So I still end up with 0, but now I have plus or minus k pi. And that's what my x equals. And then here for my pi, I have pi over 2 plus or minus k pi equals x. So now, if I ask the question, what are all the solutions between 0 and 2 pi? Are these my only 2?
No.
No. These are 2. I do have 0 and pi over 2. Those are 2 that are going to be in my list. But what other angles do I have now?
You have to add pi to them.
So if I add pi to 0, what do I get?
Pi.
So I'm also going to have pi. Do I have another one that if I add pi to pi,
2 pi.
I get 2, what?
3 pi over 2.
If I add pi to pi?
2 pi.
I get 2 pi. Now, do I include 2 pi in my list or not?
No.
Why not?
It's a parenthesis.
Because it's a parenthesis and the 2 pi isn't included. So now, if we look at the pi over 2, do I have other angles to include with that?
3 pi over 2.
I have 3 pi over 2. If I add pi, I'll get 3 pi over 2. Are there any other angles for that one? If I add another one, I'm going to get 5 pi over 2, which is going to be too big. So these are our 4 angles. For problem number 2, yes. Now, that's for the sine 2x. We still had cosine 2x plus 1 equals 0. So now we have to solve for that one as well. So for cosine 2x plus 1, we need to subtract the 1. And now we need to solve cosine 2x equals negative 1. So we're going to do the exact same thing that we did for the sine. Ignore the 2 for now. So we're solving for cosine x equals negative 1. And where is my cosine x equal to negative 1? So my cosine was equal to x over r. So we're looking for where x equals negative 1, which is down here at 3 pi over 2.
Wait,
No,
no, that's,
Oh, sorry.
no,
it
yeah,
should be up.
I apologize.
that's over here.
It should be up.
So it's, thank you, it is at, it's at pi. I apologize. So, is that our only spot where x can equal negative 1? Yes, so our only answer for cosine x equals negative 1 is pi. So when we go back to the cosine 2x equals negative 1, we're going to have that pi plus or minus 2k pi equal to 2x now. And that is actually going to give us the same answers that we got from the sine one when we had pi plus or minus 2k pi x. So we've actually already included those answers. But we have to check just in case there are additional answers that would happen from the cosine. So we still just have these 4 answers for example 2. Alright, so given example 2, I want you guys to try example 3 now. Example 2 kind of incorporates what you're going to need for example 3. So example 3 should be slightly easier now. I know a lot of you guys were having an issue with example 2, so. Example 3 should go a little bit easier now. And you guys can work with each other. You can collaborate.
As you can say in my work.
Huh?
What they say in my work, collaboration.
That sounds like a good time.
I don't know, it's
Dude. Yeah.
That was too easy. Yeah,
They're on back. Go wash.
Goodness. You're funny.
bear with me.
So yeah, that was my classic personal thing about race in my life. I needed it so much.
It looks pretty good.
And he had a good maple choice too. Yeah. Gold star.
I wish they still, like in elementary school, did Bagel Fridays because
Yes.
I was popping on a Friday morning. I'd be like, here's my 50 cents. Give me a cheese
Do we
bagel.
have other ways of rewriting?
So how are you gonna write this?
As opposed to just one that's like
That was in my favorite part of the day.
Negative cosine.
Yeah, that's really good. I have like.
Maybe you put that stress one down.
No, I'm saying, oh yeah.
That's what I'm saying.
a really nice suit.
Here's a tree.
Really pretty dress.
No.
Joey, take your tree.
Hey, so we're supposed to be working on the example.
Miss
I
Lang?
thought there was a
Oh, the physical thing.
No.
Miss Lang?
I'm just, okay,
When I did this right, I feel like this was way too easy.
Your trophy look like this.
I feel like if stuff was as simple as that,
I
it's
think you
not.
can, but I just want to get like
Okay.
wings that like.
So look at this. Your cosine x times cosine x, does that equal cosine 2x?
Oh, no, it doesn't. Oh, it doesn't. Oh, see, it
What?
was too easy.
We
Knew
just
it.
I really hope I
What's your
win
bigger
the best smile or
I really
driver.
hope I get
So I
that
just made a
stress.
big mistake.
I'm not bad.
You had.
No, I'm a good driver.
Fashion icon
Is this
and
Austin
best
Williams?
hair.
No, if I'm a bad driver, it's because like
Really?
I saw a lot of people like rushing it or.
They said,
Oh,
he said.
This audio, the only time I've ever gotten in an accident or speed is when I'm rushing it. I'm stuck because
You're stuck in a rut.
I can't get any tardies. I can't get any tardies because then they call my mom. You didn't know that? No, I do know that. I like the whole clipboard idea.
I used them too, by the way.
I like the whole clipboard idea. Because like I wouldn't know what to give someone for a class trial. What would I give them? A wig, a nose, yeah, look like crappy little. Yeah, it's like toothpaste, and toothbrush, car freshener.
Okay,
So then you said.
alright, so some of you are stuck on example 3 as well. So, alright, so there's kind of a trick with each one of these. And these are kind of the important tricks that you're gonna have to look at when you're solving these on your own. So for this one, a lot of you are rewriting cosine 2x as cosine x times cosine x. Does cosine 2x actually equal cosine x times cosine x? What does cosine x times cosine x actually equal? This is actually cosine squared x. So that cosine 2x cannot be rewritten like this.
So you rewrite like that.
Can we just do
So how can we rewrite that cosine 2x?
Cosine squared x minus sine squared x.
So we know that cosine 2x equals cosine squared x minus sine squared x. Does cosine 2x equal anything else?
Probably. It could equal tangent one, right?
Didn't we, when we talked about our double angle identities, didn't we define two other ways of rewriting cosine 2x?
Oh, two cosine squared x minus one.
So 2 cosine squared x squared x minus 1, or what was the other one?
1 minus 2 sine.
1 minus 2 sine squared x. So for cosine 2x, we actually have 3 different ways of rewriting that cosine 2x. So kind of the trick that we're looking at for this equation is you want to pick the one that's going to make this the easiest to rewrite. So some of you automatically went to the cosine squared minus sine squared x, and then you were getting stuck. Because you're going to have cosine squared x minus sine squared x minus a cosine x. And that doesn't factor, we can't pull anything out. So is there a better option of a way to rewrite that cosine 2x?
1 over.
So the 2 cosine squared x minus 1. That's going to give us all cosines still in our equation. So if we rewrote this cosine 2x as 2 cosine squared x minus 1, and then minus cosine x, we still have all cosines in our equation.
Yeah.
So the key thing to think about with these is if you have a cosine 2x and you are rewriting it in your equation, you want to pick the version that's going to give you the least number of trig functions in your equation. So in this case now we're left with just cosines with that arrangement that we picked. So that's kind of the key thing to this problem. So once I'm given this, what can I do? Go ahead, Jasmine.
You can like rearrange it so it's 2 cosine squared x minus cosine x minus 1, and then you can factor it to 2 cosine x plus 1 times cosine x minus 1.
So once I rearrange this, you realize that it's factorable. Oops. So we realize that it's factorable. That's how it factors. And then what do I do with each of those factors? I set each one equal to 0. And this looks exactly like problems that we did in 8.3. So you guys should be more than capable of finding the answers to these.
Okay, and then for the first one,
So for the first one, yes.
we will subtract the 1 and divide by 2.
So I would subtract the 1 and divide by the 2, so I'm going to have cosine x equals negative 1/2.
Yeah, so what we.
So how do I find cosine x of negative 1/2? Huh? So I make a triangle.
Oh, okay.
So if I have cosine equal to negative 1/2, where should I draw my triangle?
In the second
In the
one.
second quadrant.
In the second quadrant, because that's where cosine is negative. So we're going to use that x kind of. That'll be our angle.
Yeah.
And I can label my triangle.
Negative 1 and 2. And right there.
So what kind of triangle is this? It's a 30, 60, 90. So what's my x then?
That's
60.
It's a 60 now.
So pi over.
So what'd you say, Kara? So it's a pi over 3, yes.
So 2 pi.
Because it's in the second quadrant, yes, it's a 2 pi over 3. We're using that x as a reference angle. We're actually looking for, remember, that larger angle because we're in the second quadrant. So we get that 2 pi over 3.
Another one?
And then when would be one on the third quadrant?
So then there's another one in the third quadrant. What's my one in the third quadrant? Is 4 pi over 3. Now in this case, do I have to do the thing where I add plus or minus 2k pi?
No.
No.
No, because this time I'm just given that regular x. Now, cosine x minus 1 equals 0. So just move the 1. So then I'm looking for where cosine x equals 1. Is that where?
X over R. It's 1 over 1. So yeah.
So to explain it, yes, my cosine equals x over r. So I'm looking for where my x's are 1. Where is my x value 1?
0.
For x value?
Yeah, my x value is 1 at 0. Is it 1 anywhere else? So we get just that 0. So our answers for this one, because you guys said that I don't have to do the 2k pi thing, I get 0, 2 pi over 3, and 4 pi over 3. So those are our 3 answers. Go ahead and stop.